Hello, so this is a revision video for IB Chemistry S2.2.13, Expanded Octet and VSEPR. This is for AHL students only. The octet rule limits atoms to having 8 electrons in their outer shell, and many atoms in the periodic table follow the octet rule when they bond to other atoms. However, atoms in period 3 and beyond have d orbitals available and can accommodate more than 8 electrons. As a result, these atoms can sometimes end up with 5 or 6 electron domains around them when they form molecules, giving them an expanded octet. For example, in sulfur dioxide, SO2, the sulfur atom has 10 electrons in its outer shell. In phosphorus pentachloride, PCl₅, the phosphorus atom also has 10 electrons in its outer shell. And in sulfur hexafluoride, SF₆, the sulfur atom has 12 electrons in its outer shell. We can still use valence shell electron pair repulsion theory, or VSEPR, to predict the electron domain geometry around an atom and its molecular geometry based on the positions of bonded atoms. For example, if an atom has 5 electron regions around it, with 5 bonding pairs and no lone pairs, then the molecular geometry would be trigonal bipyramidal. If, however, an atom has 5 electron regions around it, of which 4 are bonding pairs and 1 is a lone pair, now the molecular geometry would be described as seesaw. And if an atom has 5 electron regions around it, of which 3 are bonding pairs and 2 are lone pairs, the molecular geometry is described as T-shape. If an atom has 6 electron domains or regions around it, of which all are bonding pairs, so 6 bonding pairs and no lone pairs, the molecular geometry would be described as octahedral. If, however, an atom has 6 electron domains around it, of which 5 are bonding pairs and only 1 is a lone pair, now the molecular geometry would be square pyramidal. And finally, if an atom has 6 electron domains around it, of which 4 are bonding pairs and 2 are lone pairs, now the molecular geometry would be described as square planar.